I am going to do a video on square roots and cube roots, and I have my lovely assistant here. What's your name?
Phoebe.
Phoebe. All right, so Phoebe is here to help us out. And so what you have to do is first we have to figure out what on earth is a square root. So Phoebe, I'm going to make a little square.
Okay.
All right. How big is that square?
Small.
It's small. How big is this one side? It's only 1 by 1, right?
Yeah.
Do you know what 1 times 1 is? What's one group of 1?
1.
1. Great. So 1 squared is 1. I shouldn't say this equals, because that's not true. All right, so now take a look at this, Phoebe. What if I had a square where my sides were both 2? 2 by 2. What's 2 times 2? What's 2 groups of 2? Do you know?
4.
4. That's right. Really well done. So 2 groups of 2 are 4, and that makes sense because I have 4 little squares inside. And if we continue on, if I had 3 times 3, 3 groups of 3, I don't know if you know that one because you're only in 3rd grade. What is 3 groups of 3? Do you know? Well, let's skip count. 1, 2, 3. So 3,
9.
6, 9. Great. So 3 squared is 9. Well, let's say I had a square and I knew there was 25 pieces inside, 25 little squares, and I want to find out how big were the sides. Well, what we could do is we could actually use something called the square root, and this is the symbol for the square root. So the square root of 25 really means what times itself equals 25. And if I were to check, I could say, let's see, this might work. 1, 2, 3, 4, 5, 5, 10, 15, 20, 25. So my answer is 5. The square root of 25 is 5. And so it helps to know your perfect squares if you want to be a square root master. So it looks like this. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. But remember, these are just what times itself, right? 25, 6 squared would be 36, 7 squared would be 49, 8 squared would be 64, 9 squared would be 81. Do you know what 10 squared is?
No.
What's 10 times 10?
10 groups of 10 is 100.
There you go. So you do know what 10 squared is. Which means the square root of 1 is 1, the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, etc., etc. And I'm not going to continue on, but here's the deal. If I wanted to place the square root of 7 on a number line, you might not know where to put it. But if we think a little bit, if we think logically, check this out. We know that the square root of 1 is 1. We know that the square root of 4 is 2. We know that square root of 9 is 3. Square root of 16 is 4. And the square root of 25 is 5. So where would the square root of 7 go? Between which two numbers, Phoebe? What do you think? Where do you think the square root of 7 would go?
The square root of 7 or 9?
Between 4 and 9. Excellent. So let's see. 5, 6, 7, 8, 9, 5, 6, 7, 8, 9. Well, square root of 7 sounds somewhat pretty close to the middle, so I'm going to put it somewhat near the middle. I'm not really sure. I'm going to approximate it to be there, and this is only an approximation. What about, and you're absolutely right, kiddo, what about the square root of 2? Where do you think the square root of 2 would live? Oh, I don't think she's paying attention anymore. I'm talking to you, yeah. Where do you think the square root of 2 would live? Between what two numbers?
1 and 4.
Well, between the square root of 1 and the square root of 4. So it's actually between 1 and 4. So it's going to be someplace around there. Once again, these are only approximations. And if you want to check, you could always use your calculator. Unless your calculator doesn't want to open. Here we go. Oh, I have 2 calculators now. Here we go. So if I press second and x squared, square root of 2 is 1.414 blah, 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 on and on and on. Oh, and I should mention something else. These numbers are irrational. All right, all these square roots are irrational, except for the ones that are obviously not irrational. So I'll circle, obviously that's not irrational, that's not irrational, that's not irrational. And the reason why is because they actually equal whole numbers. But these are irrational, and that's because they have decimals that go on and on forever, and they don't repeat, and they don't end. So what about cube roots? What's the deal with cube roots? Well, cube roots are similar and yet somewhat different. Cube roots are perfect cubes, and this is not one of them. 1 cubed would be 1 times 1 times 1. And 2 cubed
would be...
What would 2 cubed be? 2 times 2 times 2. Uh-oh. 2... Oops. Times 2 times 2, which would be 2 times 2 is 4. 4 times 2 is 8. And then 3 cubed, oh my goodness, 3 cubed would look something like this. And I'm going to do the best to illustrate this. You can see, if you want to see a perfect perfect cube that has 3 by 3 by 3, take a look at a Rubik's Cube. This is 3 by 3 by 3. So 3 cubed would be 27. If you took a Rubik's Cube apart, there should be 27 smaller cubes inside. Please don't take my Rubik's Cube apart. So once again, oh, don't laugh. I don't want my Rubik's Cube taken apart. So once again,
you have 10.
I don't have 10.
You have 5.
So the cubed root of 1 is 1. But the cubed root of 8 and the cubed root of 8 is 2. And the cubed root of 27 is 3. So I should have done a different number line. And that's fine. I will do a different number line. So let me pull out my ruler real quick. Let me get rid of my ruler real quick. If this was 0, 1, 2, 3, 4, 5. There's 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That'd be 2, 1, 2, 3, 4, 5. That would be 3. Remember, this is really the cubed root of 1. This is really the cubed root of 8. And this is really the cubed root of 27. So if I want to approximate where the cubed root of 15 is, I could do that by looking. Well, here's the cubed root of 8 and here's the cubed root of 27. So 15 would probably be someplace around here, the cubed root of 15. And once again, to take a look at this on the graphing calculator, well, this is a little bit trickier. You'd have to go to math, and you can see down here, cubed root of 15. And the other calculators are a little bit different, but you can see it's 2.46, 6212074, on and on and on forever, which is nearly halfway in between 2 and 3. So I was pretty close. Anyway, that's it for cube roots and square roots. If you want, you could make a list of the first few perfect cubes. I will do that for you here. That's 27. Ooh, that's not a 7, that's a 4. 27, 4 cubed is 64, and 5 cubed is 125. And that is it. All right, good luck, my friends.